Alright, a little chat about my 3 different types of molecule transport, molecule movement: diffusion, active transport, and osmosis. What I'm going to do is I'm going to go through the characteristics of each one at a time, and then I'm going to go through each particular type of molecule movement by itself just to explain it a bit more thoroughly. Alright, diffusion, the movement of molecules from high concentration to low concentration. Let's just say that this is, like the concentration of coffee in my cup. If there's more coffee here and less coffee here, then my molecules are going to move from high concentration to low concentration. Right, this is what we call with the concentration gradient. The concentration gradient is literally just a way of saying the direction that molecules want to move. Okay? Now, in active transport, you can have the same concentration gradient where molecules want to go from high concentration towards low concentration. All right? Now, the difference between active transport and diffusion is that molecules in diffusion do this automatically. In active transport, we're trying to go against the concentration gradient. So diffusion is with the concentration gradient. Diffusion is the thing that we call it when molecules go from high concentration to low concentration, when they do the thing that's happening naturally. Active transport is where molecules are going against the concentration gradient, where for some reason we don't want molecules going from where there's lots of them to where there's fewer of them. We want our molecules to go from where there are fewer of them to where there are lots of them. So active transport is against the concentration gradient. Active transport is moving molecules from where there's short supply to where there are lots of them. Okay, so against the flow. To put this into analogy, imagine that there's a river flowing along, and I want to get downriver. That's fine, I hop on a boat and I'm going to get pushed down. If I want to go upriver, I have to swim against the current or paddle up against the current. Alright? Now, which one's going to require more energy? Well, not this one. This is what we call passive. It is a passive movement of molecules. That means it requires no energy. It just happens. That's it. This, however, is active, given away slightly in the name. It requires energy to move molecules from where there is fewer to where there are more, against the concentration gradient. This requires energy. Now, diffusion and active transport, you find those in plants and in humans, and they can be used for any kind of molecule at all. This could be, for example, it could be the movement of glucose from the small intestine to the blood. Or it could be the movement of oxygen from the alveoli in the lungs to the blood. Or even the movement of carbon dioxide from the blood out into the air spaces of the alveoli. Active transport we'll know mostly because it happens in root hairs. So it could be the movement of mineral ions from the soil to root hair cells. Now, in the soil, there's only a few mineral ions. In root hair cells, there are thousands and thousands and thousands and thousands of millions. So that's going against the concentration gradient. It requires energy. Okay. Now, osmosis is a bit different. Osmosis is the movement of water from high water concentration to low water concentration across a semi-permeable membrane. All right? Now, the word for anything that allows some things in and doesn't allow others is a membrane. It's like a type of skin. So, let's say I've got a bit of water here on this side of the membrane. This is a root hair cell. Okay? How many pieces of water over here? 5. How many pieces over here? 5. Is there going to be any movement by diffusion or by active transport? Well, just looking at that picture, no. There's an equal amount on either side. But that's not the full picture, because let's just pretend that there are other things in the environment. Now, where's the high water concentration here? Here I've got loads and loads and loads of ions of some kind of a solute or a solvent. There's another thing, another molecule, another mineral at play. Over here, I don't. There's loads and loads and loads and loads of solute, solvent, ions, any other molecule over here, and not so much water. Over here, there's quite a lot of water and very, very few mineral ions. So where's the high water concentration? Well, the high water concentration is here. The low water concentration is here. So what direction are my molecules going to move? They're going to move from high water concentration to low water concentration. So my water molecules are going to move across my semi-permeable membrane. Alright? Which means eventually that these things will equilibriumize. They'll equal out. It'll become a stable scenario. Now, I don't really want you to think about concentration gradients here. What I want you to think about is movement from high water concentration to low water concentration. So forget your concentration gradient, just think of water concentration. Think about how much water is here, how much water is here, what direction is it going to move in. Now, this doesn't require energy, but so it's a kind of passive process, but it mustn't be confused with diffusion. Okay, so it is a passive form of molecules moving. It's a form of diffusion, but it's not the same thing. And examples of that, okay, an example of where my osmosis is going to be happening. Well, it's going to be happening as water moves from anything. Water movement, for example, from from the soil to root hair cells, or from root hair cells to soil, depending on where my water concentration is highest. All right. So my two passive processes, diffusion and osmosis. My one active process, active transport. Concentration gradient is the natural movement of molecules from high concentration to low concentration. Active transport is the active movement of molecules from my low area of concentration to my high area of concentration. Diffusion, because it's passive, requires no energy. It's passive because it just happens. It happens naturally. Molecules will move from where there's a high concentration to where there's a low concentration. Active transport is active. Why is it active? Well, because these molecules are naturally moving in this direction and I'm trying to move them back. Osmosis is a special case of passive diffusion. It's the movement of water from high water concentration to low water concentration across this semi-permeable membrane. So I don't look at how much solutes or ions or minerals there are, I look at how much water there is on both sides of that membrane. It's passive, and it is how water gets into root hair cells. Now, it is not the same, it is not for transport. It's not the transport of water in plants. It is not the transport of water in plants. It is merely how the plant gets water in. Transport in plants is transpiration. And there's a video on that as well if you don't know what this is. This is correct. Incorrect. There you have it.